Hello, we're going to talk about experimental probability today in chapter 10, the fifth section. And I'm not sure if the page numbers are correct. I work between two books, so it always depends which book I took it out of. But I wanted us to get these definitions down. So I'm going to pause my video and I want you guys to go look them up and write them down, and you can check them when you come back. All right, so we should be back here. And let's just quickly review an experiment. So you guys know what an experiment is. And when we talk about experimental probability, we're talking about things that actually, have happened. Like you did an experiment and this is what you came up with. In the next section, we're going to talk about theoretical probability, which is in theory. So today we're starting with the nuts and bolts of something that you actually do. And what is a trial? A trial is a repetition or an observation of an experiment. Okay. The outcome is each possible result. Sample space is all possible outcomes. An event is an outcome or set of outcomes, and what is probability? That's the measure of how likely an event is to occur. Okay, so when you talk about probabilities, they're always written as, usually actually, as a fraction or a percent or decimal. So when it's a fraction, your probability will always range from 0 to 1. And when it's a percent, it's going to range from 0% to 100%. So for example, what's the probability that Mrs. Silva has brown eyes? It's 100%. Okay, I have brown eyes. Or 1. What's the probability Mrs. Silva has blue eyes? That'd be a 0% or a 0. Okay, there's no probability. Most probabilities in the middle somewhere. Okay, so an experimental probability is the number of times an event occurs over the number of trials. So think of it as a fraction. It's a ratio, it's a fraction. And a prediction is exactly what it sounds like. It's an estimate or guess about something that hasn't happened yet. Okay, so a lot of words, a lot of definitions. Let's explain it all with some examples. So let me just first see if I can get this clearer. Here, push that. Maybe a little better. Example 1, identify the sample space. You're going to see this in a lot of your questions. And the outcome for each experiment. So the sample space, again, if you look above, and it's on your sheet there, is a set of all possible outcomes. So when you roll, and this should have a 4 here, a number 4. I made a mistake, so you can add that in there. That should have been part of the problem. When you're rolling a cube, all the possibilities that you could get go here. Okay, so we have 1, 2, 3, 4, and 6, and we have the brackets on both sides. Those are all our possible options. Now the outcome is actually what they ask for in the problem. So in this case, it's the number 4. Okay, so we're just trying to get you familiar with some of the language here. All right, spinning a spinner green. So the sample space is all the possibilities here. And I just put the first letter of these colors, but it's red, green, purple, and orange. So red, green, purple, orange. Those are all the possibilities, but what they specifically asked for in this one, the outcome that they want to achieve, is the green. Or I could have just put the G. Okay, Now, in this one, it says write impossible, unlikely, as likely as not, likely, or certain that these events happen. Okay, so at first it sounds like, what? But if it's impossible, let's look back up here at our numbers. If it's impossible, like Mrs. Silva having blue eyes, which number would that be? The 0, right? So that's your impossible. And which number was it that said Mrs. Silva has brown eyes? Well, it was the 1, or the 100%. Okay, so I'll put that over here. And then we got a middle one here, as likely as not. That means it's equally, the chances are equal. So in other words, if I tossed a dime, I have an equal chance of getting a heads or a tails. So that's in the middle here. That's our 0.5, or 50%, same thing. And so then this falls somewhere in between, and likely falls somewhere in between these two. So you can kind of, when we see these examples in A, B, C, and D, we can kind of think, where does it lie in this gamut? And that'll help us to know which answer. So what is the probability, how certain is it if a shoe is selected from a pair of shoes that it's going to fit the right foot? Okay, so you have two shoes, you have a pair in front of you, you're going to grab one. Where on this gamut is it that it would fit the right foot? Well, you have, it says likely as not, right? There's two there. You have equal chance of grabbing either shoe. So it's as likely as not. I'm going to abbreviate. Alan. Wish we had a student named Alan. And you can abbreviate it as well. Katrina correctly guesses the last digit of a phone number. Okay, well that's like 10 digits. So it's not impossible. Okay, it's not impossible. But I would go with it's unlikely. Okay. Max pulls a green marble from a bag of all green marbles. That's pretty certain, isn't it? There's no chance of grabbing anything else. It's 100% chance. A randomly selected month contains the letter R. Well, let's think about all our months. Hopefully you guys know them. So let's see how many there are that have a R in them. So January, February, March, April, May, June, July, August, September, October, November, December. Okay, so I got 8 out of 12 there, right? 8 out of a possible 12. So what is that? 8 out of 12. If you divide them both by 4, you're going to get 2/3. That's 0.67 rounded. Okay, well that's going to fall in which ballpark here? Between these two, isn't it? It's likely. It's likely. If it would have been a 3 here over 12, that would have probably been on this end, the unlikely. All right, let's take a look at the back. There's one example on the back. A manufacturer inspects 500 strollers and finds 98 have no defects. What is the experimental probability that a stroller chosen at random has no defects? Okay, so again, it's experimental because they actually inspected these. They're not guessing at this or extrapolating on this. They actually know this for a fact. And so they have 498 out of the total. Remember, the total goes in the bottom all the time. And they're looking for ones that have no defects. And the 498 had no defects. So that's why that's the number that goes on top. When you divide that out with your calculator, you'll get like a 0.99. I don't know what comes after. I don't have my calculator here. All I know is when you round it and turn it into a percent, it comes to 99.6%. So I don't know if what these two are here to make that, but you can grab your calculator and try. So that's a pretty good chance that you're gonna get one with no defects. Okay, so now let's take that information and we're gonna, in the next problem, make a prediction. The manufacturer shipped 3,500 strollers to a distribution center. Predict the number of strollers that are likely to have no defects. Well, you just figured out in here that 99.6% had no defects on their experiment. So you can take the amount of strollers and multiply it by that percent. I'm going to change it back to a decimal. And you will get what? Should be a pretty big number. It comes out to 3,486. So there's 14 of them that might have a defect out of all of those. All right, guys. Hope that helped you out. Have a great day. God bless. Bye-bye.